Segment 3, Plate Tectonics. Before watching plate tectonics, think about this. How do scientists learn about Earth's history?
This is Namibia, in southern Africa. Geologist Michael Rampino has just discovered what he's been looking for, a particular kind of rock. He's eager to compare it with another rock he extracted in Argentina, over 6,400 kilometers away.
And the rocks are exactly the same. They're basalts, and the age is 135 million years. Clearly, when these rocks were erupted, as floods of lava traveling hundreds of miles, South America and Africa were together as one supercontinent.
In 1912, a scientist named Alfred Wegener proposed that Earth was once joined together, forming one gigantic supercontinent called Pangaea. About 240 million years ago, Pangaea started to break up. Over millions of years, the continents drifted apart. It took a long time, but eventually the continents reached their present locations. Wegener pointed to supporting evidence in rocks and fossils, and to what seemed to be the remarkable fit of the South American and African coastlines, as if they were once part of the same piece of land. This idea, known as the theory of continental drift, was hotly debated. Although Wegener could show that the continents had shifted position, he couldn't explain why. Decades later, the movement of continents was explained by the theory of plate tectonics. This theory requires an understanding of the composition of our planet. Earth is composed of 4 basic layers: the crust, the mantle, the liquid outer core, and the solid inner core. The crust is hard and made up of rocks that contain various minerals. It's also relatively thin. Continental crust on land, averages just 30 kilometers thick. Oceanic crust averages just 5 kilometers. Just beneath the crust is the solid uppermost layer of the mantle. Together, the crust and the upper mantle make up the lithosphere. Under the lithosphere is another layer of the mantle, called the asthenosphere, a zone made up of hot, semi-solid material that can soften and flow. The rigid lithosphere is thought to float or move on the slowly flowing asthenosphere. Below the asthenosphere, the mantle is again solid. Earth's liquid outer and solid inner cores are extremely hot, with temperatures ranging between 2,000 and 5,000 degrees Celsius. Over the course of Earth's history, the flowing of the asthenosphere has caused the planet's crust to break into about 12 large slabs or plates, and several smaller ones. Most plates contain oceanic and continental crust. Plates move relative to one another at speeds of between 2 and 10 centimeters a year. That's about as fast as a human fingernail grows. Plate tectonics helps explain why Earth's surface looks the way it does. It has to do with what happens at the boundaries where plates meet. There are 4 types of plate boundaries: divergent boundaries, where plates spread away from each other; convergent boundaries, where plates push toward one another or collide; transform boundaries, where plates slide past one another; and plate boundary zones, broad belts in which boundaries are not well defined and the effects of plate interaction are unclear. A well-known transform boundary is the San Andreas Fault, which runs almost the entire length of California. Activity along a fault boundary can cause earthquakes. At convergent or colliding boundaries, one plate generally is forced under the other. This is called subduction. Occasionally, plates crumple, and the folded crust is forced upward. The most striking example of this is the formation of the Himalaya. Plate tectonics explains how, but not why, plates move. One possible explanation has to do with temperature changes and gravity. It takes millions of years for newly created crust to cool. As it does, it shrinks and becomes denser. Eventually, gravity pulls the edge of a plate down, causing the entire plate to move slightly. Understanding plate tectonics helps scientists anticipate where plates will move in the future. That's important because it may help geologists forecast potential natural disasters, particularly earthquakes and volcanic eruptions.
Now that you've seen plate tectonics, talk about this. What are the 4 basic layers of Earth? How does Earth's crust move?